For nearly 20 million years, something enormous ruled every ocean on Earth. Not a myth, not a legend. A real animal with real teeth the size of a human hand and a jaw wide enough to swallow two people standing side by side. The largest predator to ever hunt in open water. A creature so perfectly engineered for killing that it spent the better part of geological time utterly unchallenged. And then, without warning, it was gone. Megalodon. The very name means big tooth, and for decades, scientists thought they understood it. A giant great white shark. Bigger, slower, dumber. The stuff of Hollywood blockbusters and late-night conspiracy forums. But new research published in 2025 has changed everything we thought we knew. And the truth is simultaneously more terrifying and more fascinating than any movie ever dared to imagine. Because the real Megalodon wasn't just bigger than we thought. It was a fundamentally different animal. One that rewrites our understanding of what a shark can be, how large a predator can grow, and what happens to an ocean when the most powerful thing in it suddenly disappears. What we thought we knew. The story of how we came to understand Megalodon is almost as fascinating as the animal itself. In 1666, two fishermen off the coast of Livorno in Italy dragged up a massive shark. The locals were rattled. The local duke sent it to a Danish anatomist named Nicholas Steno, working in Florence. What fascinated Steno wasn't the shark's size, but its teeth, and how eerily similar they looked to mysterious triangular stones people had been finding embedded in rock for centuries, objects long believed to be petrified dragon tongues. Or Steno made the leap. These weren't dragon tongues. They were ancient shark teeth, preserved in rock layers formed slowly over millions of years. In that single observation, he effectively invented modern paleontology. The idea that rock strata could serve as a timeline, and that the objects preserved within them could tell us about creatures that no longer existed, was revolutionary. It reframed the entire natural world as something with a deep and recoverable history. Fast forward to 1835, when Swiss-American naturalist Louis Agassiz formally described the species and named it Carcharodon megalodon, placing it squarely in the same genus as the modern great white shark. The reasoning was straightforward. The teeth looked similar. Large, triangular, serrated, case closed or so it seemed. And a skeletal reconstruction in 1996 reinforced this idea, giving Megalodon the stocky, barrel-shaped profile of a supersized great white. That image lodged itself into pop culture and never really let go. It filled aquarium exhibits, science textbooks, and a certain Jason Statham film franchise that we'll charitably describe as loosely scientific. But by the early 2000s, cracks were appearing in that tidy narrative. When researchers conducted detailed morphometric analysis comparing Megalodon teeth to great white teeth side by side, the differences were impossible to ignore. Great white serrations are irregular and triangular. Megalodons were finer, rounder, and structurally distinct. The root shapes didn't match either. These weren't the teeth of close cousins. They were something else entirely. In 2019, that something else was officially confirmed. Megalodon was reclassified into the extinct family Otodontidae, the mega-toothed sharks. Its new scientific name became Otodus megalodon, not a great white relative at all. A completely separate and ancient lineage that split off tens of millions of years earlier, tracing its ancestry back to a shark called Otodus obliquus that swam the Eocene oceans roughly 60 million years ago. The Hollywood version of Megalodon as a pumped-up great white was officially dead. It's worth pausing to appreciate just how significant that reclassification was. For over 150 years, our entire mental image of this animal had been constructed on a false foundation. Every museum model, every film, every scientific illustration, all of it built around a comparison that turned out to be wrong. Well, Megalodon wasn't the great white's ancestor or its oversized twin. It was something that had been doing its own thing, evolving along its own path, for an almost incomprehensible stretch of time. What replaced that old image was far more interesting. How big was it really? Here's where 2025 changed everything. Because Megalodon had no bones, like all sharks, its skeleton was made of cartilage. The fossil record is dominated almost entirely by teeth and occasionally vertebrae. No complete skeleton has ever been found. Working from that fragmentary evidence, scientists had estimated Megalodon's length at somewhere between 15 and 18 meters. Enormous, certainly, but apparently that was just the beginning. This year, a team of 28 international scientists, led by paleobiologist Dr. Jakenshu Shimada, focused their attention on a remarkable specimen, a set of fossilized vertebrae discovered in Belgium, now housed at the Royal Belgian Institute of Natural Sciences in Brussels. The column measures 11 meters in length, but it only represents the trunk of the animal. The head and tail are missing. To estimate the full picture, Shimada's team built a database of proportional measurements drawn from 165 living and extinct shark species. This wasn't a simple extrapolation. It was a rigorous comparative exercise spanning the entire known diversity of shark body plans, from small reef sharks to the largest pelagic species ever recorded. Using this framework, they calculated that Megalodon's head likely accounted for around 16.6% of its total length, while its tail made up approximately 32.6%. At running those numbers against the Belgian specimen, produced a total estimated length of roughly 16.4 meters, broadly in line with previous estimates. But the story doesn't end there, because there's a second specimen, a fossilized vertebra from Denmark, significantly larger than anything in the Belgian column, measuring 23 centimeters wide. Applying the same proportional logic to that single bone produces a result that is genuinely staggering. Some individual megalodons, the researchers concluded, may have reached up to 24.3 meters in length. That is nearly 10 meters longer than previous estimates. It rivals the size of a blue whale. And at that scale, Shimada's team estimated a body weight of around 94 tons. An animal the weight of nearly a dozen African elephants, hunting in the open ocean. And doing so, as it turns out, as in a body shape that nobody had anticipated. It didn't look like you think. The size revision was extraordinary on its own. But Shimada's team also dismantled the visual identity of Megalodon entirely. While reviewing a 2022 paper that had built a digital 3D model of the shark, they noticed the underlying proportional mathematics didn't hold up. So they ran their own comparison using the same database of living and extinct shark species. What emerged was a profile that bore almost no resemblance to the creature staring back at us from museum posters for 30 years. Megalodon was not a thick, chunky, great white on steroids. It was sleeker, more streamlined, with a notably shorter, flatter snout and an almost compressed, wide-set jaw. Its pectoral fins, the long, stabilizing fins on its sides, were proportionally much larger, which makes complete sense when maneuvering 94 tons of mass through open water. In overall body shape, it bore far more resemblance to a lemon shark than the species it had long been compared to. This revision isn't just aesthetic. It's mechanically logical. Bulky, stocky body shapes create drag. That drag limits size, because at a certain point, the energy cost of moving a heavy, wide body through water outweighs any benefit. It's precisely why great white sharks cap out at around 7 meters. Any bigger in that body plan, and they sacrifice the speed that makes them effective predators. Megalodon's leaner profile meant it could keep growing without hitting that wall. Yet it's the same principle that allows blue whales to reach 30 meters. Their hydrodynamic shape enables efficient locomotion at scales that would be physically impossible for a stockier animal. And that same sleek design likely explains why megalodon teeth have been found on every single continent except Antarctica. It was a global predator with the physical architecture to match. Think about what that global distribution actually means in practice. Megalodon wasn't confined to warm tropical shallows. It was ranging across hemispheres, covering thousands of miles of open ocean, hunting in conditions that varied enormously in temperature, depth, and prey availability. For a single species to maintain that kind of geographic reach across millions of years requires not just physical capability, but extraordinary biological flexibility. And the new body shape helps explain both. A streamlined frame reduces the energy cost of long-distance travel. Mesothermy, the ability to regulate body heat independently of surrounding water temperature, removes the thermal constraints that restrict most fish to narrower climate bands. Megalodon was, in the truest sense, built for the entire ocean. The same research also revealed something deeply unsettling about Megalodon's earliest moments of life. Fossilized evidence suggests that newborn megalodons entered the world already measuring between 3.6 and 3.9 meters long. For context, that is larger than a fully grown adult great white shark in some populations. And like modern great whites, they almost certainly practiced intrauterine cannibalism, embryos consuming unfertilized eggs inside the womb to fuel their own development. Megalodon's existence was a competition from the very first second of its life. The largest animal ever to hunt in the ocean began its life by consuming its own siblings before it had even drawn its first breath of seawater. Why did it disappear? For a predator this dominant, this adaptable, this physically refined, extinction seems almost insulting. And yet, around 3.6 million years ago, the teeth stop appearing in the fossil record. No gradual fade, no geographic retreat. Just silence. The cold water theory was popular for a long time. As the planet moved toward the ice ages, ocean temperatures dropped, and some researchers suggested Megalodon simply couldn't cope. But the data doesn't support it. Analysis of Megalodon's global fossil distribution shows it was capable of inhabiting colder latitudes throughout its existence, and its decline doesn't correlate with any known temperature trend. Evidence also suggests Megalodon was likely mesothermic, partially warm-blooded, capable of maintaining body temperature above the surrounding water. Cold alone didn't kill it. What the fossil record does show is a catastrophic collapse in Megalodon's food supply. Researcher Catalina Pimiento found that Megalodon's global abundance peaked during the Middle Miocene, roughly 11.6 to 16 million years ago, before entering a long, steady decline. And that decline coincides almost exactly with a devastating loss of the large marine mammals Megalodon depended on. During the Pliocene, extinction rates among marine megafauna were staggering. 55% of large marine mammals disappeared, along with 43% of sea turtles and a significant proportion of large sharks. And the buffet that had sustained a 94-ton predator for millions of years was running dry. Consider the math of feeding something that size. A 94-ton predator requires an enormous caloric intake simply to maintain basic biological function. Estimates suggest Megalodon may have needed to consume hundreds of kilograms of energy-dense prey on a regular basis, when the whale populations it depended on began to collapse. Megalodon wasn't just facing lean times. It was facing a situation where the ocean could no longer physically support the energy demands of an animal its size. Every meal became harder to find. Every unsuccessful hunt represented an energy deficit the animal couldn't easily recover from. Over generations, that pressure would have been relentless and cumulative. Shifting sea levels compounded the problem. Pliocene fluctuations likely reduced the coastal shallow water habitats where prey was most concentrated, pushing Megalodon into harder, leaner hunting conditions with every passing millennium. And into that increasingly scarce resource landscape stepped a smaller, faster, more energetically efficient competitor. The great white shark, needing far less food per day to survive, occupying many of the same ecological niches, and perfectly adapted to the changing conditions. The great white was the David to Megalodon's Goliath. The animal that Megalodon had long been mistakenly grouped with may have played a direct role in driving it to extinction. The irony is almost poetic. Is it still out there? The question refuses to die. Could Megalodon still exist somewhere in the deep ocean? Is it hiding in the Mariana Trench, simply waiting? It's a compelling idea. And it received a massive boost from a 2013 documentary that presented supposed evidence of living megalodons. Blue whale carcasses with enormous bite wounds, giant fins, pictures photographed near the surface, scientist interviews, and dramatic on-location footage. Millions watched it. Many were convinced. There was, however, a disclaimer at the start of the program stating clearly that the content was not based on fact. The footage was fabricated. The scientists were actors. The entire production was fiction dressed as documentary. The deeper scientific case against Megalodon's survival is airtight. It was an apex predator operating at the very top of the ocean's food chain. If it were alive today, orcas and great white sharks would never have filled its ecological role. Those vacant niches simply wouldn't exist. Whale populations, which exploded in size after Megalodon's extinction, would look dramatically different if a 24-meter predator were still hunting them. And in an era of global maritime traffic, underwater acoustic monitoring, satellite tagging programs, and deep-sea research submersibles, something the size of a blue whale would not remain undetected. The argument that only 5% of the ocean has been explored sounds compelling on the surface, but it fundamentally misunderstands scale. A 94-ton apex predator doesn't need to be directly observed to leave a detectable ecological footprint. Its presence would be written into the behavior of every species around it. Prey animals would show avoidance patterns. Carcasses would wash ashore bearing unmistakable marks. The ocean is not a passive void. It is a deeply interconnected system, and something Megalodon's size would leave fingerprints everywhere. As for the Mariana Trench specifically, Megalodon teeth found near it in the 19th century were dated to as recently as 11,000 years ago, briefly fueling real speculation. Reanalysis revealed those teeth were exceptionally well preserved due to a thick coating of manganese dioxide that dramatically slowed decomposition. They were ancient. And even setting that aside, the trench simply cannot support an animal this large. Food is critically scarce at those depths. The deepest dwelling fish ever recorded, the snailfish, reaches only about 20 centimeters in length and lives at the absolute limit of what the environment can sustain. A 24-meter predator in that environment wouldn't be lurking. It would be starving. What Megalodon leaves behind. For 19 million years, Megalodon was the defining presence in the world's oceans. It shaped the behavior of every species it shared the water with. Whales evolved in its shadow. Entire ecosystems were organized around its hunger. And when it finally disappeared, the ocean reorganized itself entirely around its absence. Whale populations surged, new predators expanded their ranges, and the marine world recognizable today began to take shape. The fact that blue whales exist at the size they do is, in some sense, a direct consequence of Megalodon no longer being around to prevent it. Before Megalodon's extinction, whale species were measurably smaller across the board. Evolutionary pressure from an active apex predator of that scale keeps prey populations in check in ways that extend even to physical body size. Remove that pressure, and the constraints disappear with it. And science is still revising its understanding of what this animal actually was. The 2025 findings didn't close the book. No complete skeleton has ever been recovered. Every conclusion is still extrapolated from teeth and vertebrae and comparative anatomy. The true scale, 24 meters, 94 tons, remains an estimate built on the best available evidence, and future discoveries could reshape it again entirely. A single well-preserved skeleton, if one exists somewhere on the ocean floor waiting to be found, could overturn decades of assumptions in an afternoon. That uncertainty is, in its own way, the most fitting tribute to an animal that spent nearly 20 million years being fundamentally misunderstood. Whatever it was extraordinary. And whatever it looked like, and it was nothing like anything we ever imagined. Until someone finds the body, the full truth of Megalodon remains exactly where it has always been, somewhere beneath the surface, just out of reach.